Hi guys, this is 8.3 medians and altitudes of triangles. Our essential question is how can you find the balance point or center of gravity of a triangle? Our answer is basically you graph or find the equations for at least two of the three medians, so that's a new word, of the triangle. The centroid, which is the balancing point of the triangle, will be located at their intersection. Okay, so let's look into those words and what I'm talking about. So, the balance point. So, if you were to find the balance point, you need to be able to create a median. So, a median of a triangle is a segment whose endpoints are at a vertex of a triangle and the midpoint of the opposite side. So, basically, you have to be able to know that there's a midpoint between the opposite side, in this case, AC. Okay, again, that means this side from A to that midpoint is congruent to the midpoint to the other vertex, C. And then once you find that midpoint, you draw your median from the opposite vertex, okay? And then basically do the same thing with B to C, find your midpoint, draw your median, and then you could do the same thing, find your midpoint for AB, and draw your median. Okay, those are medians. Now, most of your turns from this video are just basically the construction of your medians and your centroid. So you're going to have to draw your own triangle. Go ahead and draw it. You can use it in your folder, your notebook, separate sheet of paper. Just make sure you staple your constructions into your notes. It's going to count as your notes, okay? So first things first, you're going to need a compass again. All right, so it's an ugly compass, I know, but you're definitely going to need one. Okay, one's going to have a pencil or a marker in, depending on what you put in to the one side, and then you have your pointy end. All right, so use a compass because you are constructing. All right, so what I want you to do is put once you draw your triangle, put the pointy end on point B. Hopefully, you labeled it point B, and then you're going to have your pen and you're going to draw an arc with your compass. Okay, like that. And then once you have your arc, you're gonna switch places, put your pointy part on C. Make sure you do not adjust your angle, all right, or the distance between your pointy and your pencil when you do this. Okay. And you're gonna draw your second arc. So let me clean it up. And what you should see after you construct those two arcs is these two intersections. With those intersections, you should be able to draw this line. Okay. That is a perpendicular bisector. Okay. That means you just found the midpoint. Okay, see that intersection here between that line that you just drew? That's the midpoint for BC. Now, on the opposite side, we have vertex A. Okay, so what you're going to do is you're going to go ahead and draw your first median, which should look something like that down here. Okay, so when you use your compass, you're able to find your midpoints, and then you drew your line. Okay, and that was your first median. You're going to do this two more times. So after you draw A to, we'll call it X, you're going to find the midpoint for AB. Okay, so use a compass, do the whole thing just like you did with the arcs. If you need help, come see me. And then you're going to draw your second median, and then you're going to find the midpoint for AC and draw your third median. Okay, you should have something in the end that looks like this. All right, now, fun fact point P, that is your centroid. Also, here are the verbal descriptions, just so you have a good idea of what's going on verbally. All right, centroid theorem. So again, centroid's created by two medians. So there's our centroid, but there's a theorem that came about and it was proven, okay? And every single time this happens. So basically, the centroid theorem states that a centroid of a triangle is located two-thirds of the distance from each vertex to the midpoint of the opposite side. So basically, what they're saying is AP, okay, if we look at AP from here to here, that's going to be two-thirds of that whole median, which is AX. All right. And then it's going to be the same way for all the other two medians, okay? So BP this guy to this guy, he's also 2/3 of his median, which is BY, and the same thing with CP. All right, so CP, he's also 2/3 of his whole median, which is CZ. All right, and that's basically what the theorem states. Now, in applying it, it's not that bad. Basically, we have our three medians, all right, BD, AF, and EC. And basically, what's happening here is they want us to find AG. All right, so AG is this little piece right here. Well, we know that's 2/3 of the median that he belongs to, which is AF. Okay, so we know the setup AG equals 2/3 of AF, and nice of them, they already told us that AF is 9. So we'll go ahead and substitute in for AF. And 2 times 9 divided by 3, AG equals 6. Very nice. All right, so your turn number 2. It looks a little bit more complicated, but it's really not that bad. So let me explain. Here, let's erase all these. Okay, so GE, we have to find GE. So let's see, let's mark it. GE is this little piece. Okay. And they did tell us that CE, all right, that whole median is 7.2. Okay, that's good to know. And we know that GC is 2/3 of that whole median. Okay, so that's something to be aware of. Now, centroid theorem. So basically, CG, okay, again, we know is 2/3 of that whole median. And they did give us the whole median. So plug it in. And then once you substitute it in, you're going to get your answer. Okay, CG equaling something. And then you know that CG plus whatever you had for CG, I'm sorry, not for CG, for, let's see, we're asked about segment addition postulate. So CG plus EG, or GE, I think, yeah, there we go, equals that whole median, which was CE. Thank you, Penn, for making life wonderful. There we go. All right, so once you have that substitution property, so whatever you got for CG, you're going to subtract it from what you know is CE, which is 7.2. And then you should be able to get your answer for GE, okay? All right, good luck. All right, so the last thing to talk about is connected to the idea of medians and well, what the other guys create. And what I mean by the other guys is the altitudes. So, like the median, the altitude does start at the vertex, but it doesn't care about the whole midpoint. It just cares about 90-degree intersections with the opposite side. So basically, an altitude of a triangle is a perpendicular segment. So again, when you see perpendicular, think 90 degrees from a vertex. So again, it's coming from a corner or an angle to the line containing the opposite side. All right. So it's kind of like a median, except it doesn't care about the midpoint, just cares about the 90-degree intersection. So if we look here in this image for triangle ABP, AX, all right, AX, let me use a highlighter here. AX is at an altitude, all right, and BZ is also an altitude. Notice how, yeah, they technically come from vertexes, and they also hit a certain point at a 90-degree angle. And then CY is right here, and it's actually inside the triangle, so that's good to know. Um, and notice how AX and BZ are on the outside of the triangles, okay? They can actually exist. Altitudes can be inside, outside, or on the triangle. That's like a little fun fact because they really just care about the vertex and the whole perpendicular segment, okay? So the altitude of a triangle is often called the height of a triangle. So if you were to talk about this entire triangle, the bigger triangle, okay, a triangle ABP, this would be considered his height, okay? And that's that 9-degree perpendicular uh, bisection that altitudes rely on. Now, the orthocenter is basically an intersection or point of concurrency. So there's multiple lines coming through that are more specifically altitudes. So altitudes create orthocenters. So orthocenters contain altitudes. So again, the big thing, the common mistake here is the difference between medians. Again, medians, we care about the midpoint. Okay. Okay, so there's a median. Altitudes, we don't care about the midpoint. We care altitudes. What we care about is whether or not it's 90 degrees or not. Okay, so that's the difference. Okay, guys, if you have any questions with the constructions or needing help with the math, just come see me, let me know, and have a great day.